Hey friends, Azure Load Balancer now offers a new tier in standard SKU called Global Tier. When creating a load balancer with Global Tier, you now have a cross-region load balancer, which provides regional redundancy and low latency traffic routing. Irene is here to show me how it works today on Azure Friday. Hey friends, it's another episode of Azure Friday. I'm here with Irene Huang. How are you?
I'm good, Scott. How are you?
I'm excited to hear from you because there's always big networking problems that I'm trying to solve, and you're going to talk to me about cross-region global load balancing. And I've been doing load balancing for many, many years, but I'm worried that maybe I wasn't doing it very elegantly.
Yeah, Scott, absolutely. So let me tell you a little bit about Cross-region Load Balancer. So it is a layer 4 network global load balancer that supports TCP and UDP traffic. It routes your packets using Microsoft Global Backbone instead of the internet. So it really provides you with that efficient routing. And it also enables you to scale out across regions with high and predictable performance. So you only need to maintain the one global front end to your end customers or your upstream applications while you scale out in a region or across regions without really impacting that global front end. And just as any other layer 4 pass-through load balancer, we do provide you with that client IP preservations, so you don't really need any extra setup to preserve the originating IP of your packet coming in. And along with the cross-region load balancer, we're introducing this new load balancing algorithm based on geo-proximity. And what that means is that once a packet arrives at the global front end, we know the entry region where your packet comes into Azure, and based on that entry region, we'll then route your traffic to the closest regional deployments. And here is an example where we can see the geo-proximity load balancing.
You want to go ahead and share your screen?
Yeah.
Yeah, back in the day, I was doing things with DNS, and it was pretty sloppy. We would just go, Hanselman.com, and you'd have www.1.hanselman.com. That wasn't very
Yeah.
elegant. So you
Yeah.
mentioned we're at layer 4. A lot of people may not be familiar with the OSI layers, but can you help me understand the difference between like layer 4, a DNS load balancer, and then the things that we see with like HTTP load balancers at layer 7?
Yeah, absolutely. That's a great question, Scott. So today, at least for a public internet-facing application, there are a lot of alternatives. The first one is a layer 7 global load balancer. For that one, so customer who wants to use it for HTTP or HTTPS traffic, it is a great solution. But for some customers who would want to use it for, let's say, TCP or UDP traffic, they might want to use a layer 4 network load balancer, just as our cross-region load balancer. And yeah, of course, some customers use DNS-based solutions, but there are some common challenges that they might be facing. The first one is sometimes they could experience some long failover time due to DNS caching issues, for example. And so if the customer's application is very performance sensitive, then cross-region load balancer is a great fit. So we do have built-in health probe that probe your regional load balancers constantly. And once we detect a region failure or server failure in that region, we'll then take that server out of the rotation and the regional deployment as a whole out of rotation so that the traffic will be rerouted to the next closest healthy deployments. And another common challenge for a DNS-based solution is that you'll still have to manage a group of IPs. So for customers who don't want the responsibility of having to manage a group of IPs, cross-region load balancer is a great fit where we take care of the management for you while you just focus on making a better product for your end customers.
Fantastic. That is such a wonderful answer. Thank you for that clarity.
Of course. So as you can see here, let's say, for example, you are a company that's holding a myfashion.com website. As you can see here, you have two web servers in the backend, basically responsible for rendering the web content. So what a cross-region load balancer helps here is that it routes customers to the closest web server instead of just randomly whatever web server, right? So you can see here, if customers based in US, then they're expected to hit the web server in West US instead of the one in West Europe. And so that really gives your application that high efficiency and low latency that really provides your end customer that great customer experience. Last but not least, Cross-region Load Balancer also provides you with the failover behind the global front end. So jumping back to our example here, as you can see previously, this is what happens when two servers are both up and running. Customers are accessing respectful web server based on the geo-proximity. And what happens if a web server goes down? Now, what you can see here is that customer that was supposed to hit web server 1 is now routed to the next closest healthy regional deployment, which is web server 2 in West Europe. And so this really gives you that regional resiliency for disaster recovery. So if in an event of a region goes down or a server goes down in a region, your end customer is still not impacted by accessing the server further away, but up and running. All right. Next, let's see what the cross-region load balancer's configuration looks like. So as you can see here, from regional layer all the way to the backend pools, it's just your normal day Azure load balancer setup. So for a lot of our customers, you might already have several load balancers set up in different regions. And what happens if you just want that cross-region ability for your regional deployments? All you need to do is to create a cross-region load balancer and just put those regional deployments that you already have in the backend of the cross-region load balancer. And voila, there you have it. So in a demo that I'm going to present next, I've already created two regional deployments, one in West US and the other in West Europe. So you'll see that I will have a West US LB and a West Europe LB. And what I'm going to do is I will walk through the creation of cross-region load balancer, and then I'll just put those two regional deployments I already have in the backend pool, and we'll go from there.
Very cool.
Great. Awesome. So now we're at the portal page. We're going to first create a resource group. All right, let's call it Azure Friday. And look, region East US, that's cool. All right, let's hit create. Awesome. So now we're going to create a cross-region load balancer. Let's find our load balancer first. There we have it. All right, we'll create this one in our resource group that I just created, and let's call it cross-region LB. All right, and let's put it in East US 2. And here we'll say tier, a standard SKU and tier global. So that's how you create a cross-region load balancer. And one thing I would like to call out here is we do have regions where you are able to put your cross-region load balancers in. And so those regions are called home regions. So they are the regions where basically the configuration states of the load balancers are held in. And now some people might ask, what happens if a home region goes down? So that's a great question, but when we design our cross-region load balancer, we deliberately separated the configuration states and the data processing components. And so in the event of a region failure, it doesn't really impact the data flow of the cross-region load balancer. It'll still be able to accept the traffic flow, and it'll still be able to forward the traffic flow to the backend. It just means that during a region failure, you won't be able to configure your cross-region load balancer at that time. So make sure you've selected a home region, and you can learn more here. All right, so let's call our public IP cross-region LB IP. And let's hit review and create. Awesome. So now what Azure's doing in the backend is it's creating that public IP that is a global Anycast IP, and it's also creating a cross-region load balancer that is using that IP.
When this is happening, one of the things that just blows me away is that software-based networking is just such a miracle that people don't appreciate. Like, we used to hire consultants to fly in from other cities to bring the load balancer, the local load balancer, and then rack it into the machine now. And the idea that you and I can go and do a global load balancer without calling anyone, no one has to go into a giant warehouse and rack a machine and plug in wires, is such a miracle. I just wanted to comment on that because it's so cool.
Absolutely, it's our goal to cut the cost and save the time for our customers.
Fantastic.
All right, so as you can see here, we already have our front end created for us, and this is the IP that we're going to use a lot later on. All right, so let's go create our backend pool. Let's call it backend pool 1. And so what you can see here is instead of the normal backend pool that consists of maybe public IPs or network interfaces, now we have a backend pool composed of load balancer. And what those load balancers are your regional load balancer that is bound to a region. So remember, I said I already created 2 load balancers, one in West US and one in West Europe. So what we're going to do now is we're going to add them to this backend pool. So this is my first load balancer, and my second is called West Europe.
It's kind of a family tree of load balancers.
That's correct. That's correct. All right. Let's go back. Awesome. All right, let's go to health probe, and we're just going to create a health probe that probe the port, which is 50,000. Now, this is the port that my regional load balancer is listed on. And one thing I would like to call out here is today with cross-region load balancer, we use a default of 20-second as the interval to probe your regional load balancers. And in the future, we will be adding on the roadmap the configurable health probe, where you will be able to configure your health probe for shorter intervals so that you have a shorter failover time.
Cool.
All right. Awesome. Now, last, we're just going to create some load balancing rule. Let's call it LB rule. I'm just using IPv4 because my front-end IP is a IPv4. I'm keeping the protocol here. I'm changing the port to the port that my regional load balancers listen on. So one thing I would like to call out here is make sure that the backend port matches with the front-end port of the regional load balancer. So what I mean by that is, for example, let's say I have 50,000 here, and what I should verify next is the public IP of the regional load balancer should be accessible at this front-end port, right? So make sure you have that.
Mm-hmm.
All right, so we only have one backend pool, that is our backend pool, and one health probe. So I'm keeping session persistence as none here, but you're free to go for client IP, session persistence, or the combination of client IP and protocol for your session persistence.
Why would I change that? Does it really just depend on the architecture and the behavior of my application? If I were writing maybe a chat application, I might want session persistence based on client IP.
Yeah, so for example, some of our customers have authentication built in, and so sometimes it needs more than 2 or more than 3 connections to really, for that connection, for that authentication to go through, and so they would want the connection to keep going to the same server after time and time until the authentication goes through, and so that's where you want to use session persistence.
Thanks.
Yeah. And you'll be able to configure idle timeout between 4 and 30 minutes. I'm just keeping 4 minutes here. You can also enable TCP reset and floating IP. And so what floating IP means here is that once you've enabled floating IP, the packet that arrives at the virtual machine in the end will have destination IP showing as the global IP of the cross-region load balancer instead of the NIC IP. That will happen if you don't have floating IP enabled. All right, so let's hit OK. So after this, we should be able to access our cross-region load balancer via that IP and the port that we just set up in the load balancing rule. So let's see if that is the case. So what I'm going to do here is I'm going to ping this IP with this port. So what I'm expecting to see here is I'm expecting to see myself hitting the West US server because I'm based in Seattle, and I know my cross-region load balancer have 2 regional deployments, one in West US and one in West Europe. Now, based on that geo-proximity load balancing algorithm, I should be hitting the West US server. So let's see if that is the case. All right, it says hello world from West US. Awesome. Now, what I have is a West Europe VM in a totally another resource group. So I'm going to RDP into this VM, and I'm going to basically ping the same IP and the same port. And what I'm expecting to see there is I should be able to see hello world from West Europe. Now let's see if that is the case. All right, so now we're inside the West Europe VM. Let's first copy paste this IP and port, and basically just copy paste it into the Internet Explorer that we just opened. And there we have it, hello world from West Europe.
Wow.
So now we've, yeah. So now that we've verified the geo-proximity based load balancing algorithm, let's see what the failover looks like in event of a server failure in a region. So what I'm going to do here is I have this virtual machine up and running, and this is the virtual machine that is powering the whole West US deployment. And I have an IIS server up and running that's basically serving the hello world from West US prompt. So I'm going to connect into this virtual machine. I'm going to stop the IIS server. And we're going to refresh this link again. And what we're expecting to see is this will change from West US to West Europe. All right, let's see if that is the case. All right, let's open up command prompt. All right, so now the IIS server is stopped. What's happening now is the regional load balancer's health probe will detect the backend failure. And because we only have one server in the backend, now the whole regional load balancer is not accessible. The data path availability is reporting down. And the cross-region load balancer will then detect, oh, this whole regional load balancer is down. Let's reroute traffic to the next closest region. And there we have it.
That's crazy. So it was just five. You said, I remember you said it to 5 seconds, right?
It's actually 15 to 20 seconds, but usually around that range.
So what would have happened during that 5 seconds? What happens in that moment where it's failing, but it hasn't failed yet?
Yeah, so what happens is a health probe basically of the cross-region load balancer will keep probing. And based on that interval, which is set to 20 seconds by default, in that 20 second, we'll realize, oh, okay, your regional West US deployment or West US LB is reporting unhealthy. Mm-hmm. And so we'll take that LB out of the rotation once we've detected that you're unhealthy. And then once the new packet comes in, we'll route the traffic out of the new rotation, which doesn't include the West US deployments. Will
a couple of my customers maybe have a longer connection time, or will they have failed connections during that moment? I see that the load balancer is being removed, but there's a tiny window there. What is the client experience?
Yeah, so you might experience this browser keeps refreshing or keeps trying to connect for that 15 seconds, but after that you should be able to see the connection up and running.
Yeah, and we saw right just then that was incredibly fast and was really just a matter of seconds.
Yeah, for sure.
Very cool. So folks can do this today, right? This is available now.
That is correct. So today you'll be able to deploy a cross-region load balancer in Portal or in CLI or in PowerShell. All are available.
Fantastic. This is great. An instant global failover for the next optimal regional deployment. It doesn't just fail over, fails over to the next one that's appropriate for your region. So you gave an example where we had West US and West Europe. You can use all the Azure regions, can't you?
That's a great question. So you can use all the regions, but basically for regions that are advertising your IPs, they're called participating regions. But for the backends, you can put whatever regions you want in the backend, right? But a participating region means that it is the region that is advertising your IP. And so conveniently, let's say if you have a participating region in the backend and your traffic is actually coming from the participating region, what that means is that your packet doesn't even leave the region. So it's really the most efficient way of routing your traffic without inter-region traveling. But let's say if the traffic is originally from a non-participating region, and the traffic will be routed to a participating region and then to a backend region that is closest to this participating region. But in the backend, you can theoretically put whatever region you want.
Very cool. I love new features that make me feel more powerful, and I feel like cross-region load balancing is one of those features.
Yeah, absolutely.
Great. Thanks so much for chatting with us today.
Thank you, Scott.
I am learning all about how to build highly available applications with cross-region load balancers today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.